Hello, welcome to all. In this class, we are going to see about the subject measurement and instrumentation. So, our first unit is the introduction to measurement and instrumentation. First, let us see what do you mean by measurement. So, measurement is nothing but the act of quantitative comparison between a known standard and an unknown quantity to be measured. This is called as measurement. Unit 1 is Introduction to measurement. First, we will see what is measurement. Measurement is the process by which one can convert a physical quantity or parameter into a meaningful number. So, you can convert the physical quantity or parameter into a meaningful number is called as measurement. So, we can define measurement as the measurement of given quantity is the result of quantitative comparison between a predefined standard and an unknown quantity to be measured. Is called as measurement. So, you can measure the unknown quantity by comparing with the predefined standard is called as measurement. The example for measurement is 1 liter of water, 1 kg of vegetables. So, the quantity like water and vegetables are measured with the help of comparing with the predefined standard. So, for the results of measurement, to be meaningful, there are two basic requirements. First one is the comparison standard used for measurement is accurately measured and must be commonly acceptable. The second one is the procedure and the instrument used for measurement must be provable. So, the result of measurement to be meaningful, there are two basic requirements. One is the comparison standard which is used for measurement must be accurately defined and it should be commonly acceptable, and second one is the procedure and instrument used for that measurement must be a provable one. Next, let us see what is instrument. It is defined as a device for determining the value or magnitude of a quantity or a variable. It is defined as a device which is used for determining the magnitude or the value of the quantity which is to be measured is called as instrument. Example for instrument is weighing scale, ammeter, voltmeter, etc. So, the device which is used for determining the value of a quantity which is to be measured is called as instrument. So, the major problem with this instrument is error. So, what we have to do is, in order to reduce or in order to minimize the error, we have to use or we have to select the proper instrument, and a proper procedure should be followed in order to reduce the error while using instrument. So, the instrument which is used for measuring that quantity should not disturb the quantity which is to be measured. Next, we will see what is measurand. We have seen what is measurement and what is instrument. The third one is measurement. So, the physical, chemical, electrical quantity or a variable to be measured is called as measurand. So, the measure is nothing but it may be a physical, chemical or electrical quantity or a variable which is to be measured is called as measurand. Next, we will see what is a physical quantity. The quantities which can be measured by an instrument and by means of which we can describe the law of physics is called physical quantity. So, the quantity which can be measured directly with the help of an instrument and by means of which we can describe the law of physics is called as physical quantity. So, the example for physical quantity is length, velocity, acceleration, force, pressure, etc. So, these are the various physical quantities which can be measured by the instrument and which describes the law of physics. Next, we will see what is unit. The standard measure of each kind of physical quantity is called as unit. So, the unit is defined as the standard measure of each kind of physical quantities is called as unit. So, physical quantities like length, mass, velocity can be measured with the help of this unit. So, the formula to find the magnitude of physical quantity is the product of numerical ratio into unit. So, the magnitude of a physical quantity can be found with the product of numerical ratio and the unit of that physical quantity. What is numerical ratio? It is the number of measures, that is number of times the unit occurs in any given amount of the same quantity is called as numerical ratio. Example, 1 liter of water. So, 1 liter of water, the quantity to be measured is the water, and here the liter represents the unit, that is it is the mass of water. So, the unit liter represents the mass of water, and the value 1 or the numerical value 1 represents the numerical ratio of that quantity which is water here. So, 1 is the numerical ratio, liter is the unit which represents the mass of water, and the quantity which is to be measured is water. Another example is 1 kilogram of vegetables. So, here the quantity to be measured is vegetable, and the kilogram represents the unit of mass, and 1 represents the numerical ratio. So, the numerical ratio of a quantity alone does not have any meaning without the unit, that is 1 kg. Without the unit kg, this numerical value 1 alone does not have or does not give any meaning. So, the numerical ratio along with the unit will give a magnitude of that physical quantity. Next, let us see the classification of physical quantity. So, this physical quantity is classified into 3 types. One is fundamental quantity, then derived quantity, third one is supplementary quantity. This is classified into 3 types: fundamental quantity, derived quantity and supplementary quantity. Next we will see the properties of units. The first property of units, the unit must be well defined and must be of proper size. The second one is the units must be easily reproducible, and third one, the units must not change with time. Also, the units must not change with physical conditions like temperature, pressure, etc. So, these are all the properties of units. The units which are used must be properly defined and must be of proper size, and the units must be easily reproducible, and the units must not change with time or with any physical conditions like temperature, pressure, etc. So, from the past there are various number of system of units have been followed throughout the world like CGS, MKS systems. So, based on that we will see the classification of system of units. So, the system of units are generally classified into 3 types. First one is the CGS system. So, CGS represents the centimeter, gram, second system, where the centimeter represents the unit of length and the gram represents the unit of mass and second represents the unit of time. So, these 3 basic quantities are used to represent the fundamental quantities in CGS systems. Along with these 3 quantities, one more quantity called fourth quantity is included along with the CGS system, that is the permittivity epsilon of the medium is included as the fourth quantity with this CGS system. So, this CGS system with this fourth quantity permittee is called as electrostatic CGS system, or otherwise we can call it as ESU system of units. ESU represents electrostatic unit system of units. And along with the CG system, another quantity called permeability is included as the fourth quantity. So, the CG system is called as electromagnetic CGS system, or we can call it as EMU systems, electromagnetic unit of systems. So, one is the first system, that is CGS system, which has the base quantity centimeter, gram and second, and the fourth quantity permittivity and permeability is added along with the CGS system. So, the next system is the MKS system. So, M represents the meter, kilogram and second system. So, meter is used to represents the length, kilogram for mass and second for time. So, this has been used. The system which uses this quantities like meter, kilogram, second for represent the physical quantities are called as MKS systems. And third one is called as FPS system. So, FPS, F represents the foot, P represents the pound and S for second, foot, pound, second system. So, the system which uses the quantities foot, pound and second to represent the length, mass and time is called as foot pound system. So, the CGS system, MKS and FPS, these three systems are called as absolute systems. So, these three types of systems has been used throughout the world. So, there is no uniformity in using the system of units throughout the world. So, in order to follow the common system of units throughout the world, and another system of units have been found, that is called as SI units. So, this SI units is used to commonly represents the units throughout the world. So, an international organization in the General Conference on Weights and Measures has recommended this common SI system as a unified system throughout the world. So, SI represents the system, international D units, system of units. So, the SI system is commonly used throughout the world for the sake of uniformity. Next, we will see the classification of SI system. So, this SI systems is classified into three types based on the quantities like fundamental units, derived units and supplementary units. So, based on the physical quantities, these SI units are classified into fundamental units, derived units and supplementary units. First, let us see what is fundamental quantity and its unit. So, the fundamental quantity is also called as base quantity and its base units. So, we can define the fundamental quantity as quantities which are measured directly and the units which are used to define the quantities are called fundamental units or base units. Base units. So, the quantities which can be measured directly are called as fundamental quantities and the units which are used to define that fundamental quantities are called fundamental units or base units. The example for fundamental quantity is, we will take a base quantities or fundamental quantities, name of the unit and the unit symbol. The first base quantity is length. The unit of length is taken as meter. The symbol is m. Second quantity is mass. The unit is kilogram. The symbol is kg. The third quantity is time. This unit name is second and symbol used is S. Fourth one is electric current. The unit is ampere. The symbol used is A. Then temperature, unit is Kelvin, symbol is K. Next quantity is the amount of substance. The unit of amount of substance is taken as mole, symbol is MOL. And luminous intensity, and the unit for luminous intensity is candela, which is represented as CD. So, these are the base quantities and the unit for base quantities, and the units used to represent these base quantities are called as the fundamental units or base units. Next we will see, the first one is fundamental quantity. Next we will see the supplementary units. So, the units other than the fundamental and derived units are called as supplementary units. So, in the supplementary units we have two quantities. One is the plane angle, which is represented as theta or phi. This plane angle is defined as the angle subtended by an arc of circle equal in length to the radius of the circle is called as plane angle. So, plane angle is the angle subtended by the arc of a circle whose length is equal to the radius of the circle. So, the unit of plane angle is radian, which is represented as symbol is. The second supplementary unit is the solid angle. So, the solid angle is represented as phi s or theta s. You can define solid angle as the angle subtended at the center of the sphere by the surface whose area is equal to the square of the radius of the sphere. So, the angle subtended at the center of the sphere by the surface whose area is equal to the square of the radius of the sphere is called as solid angle, and the unit of solid angle is steradian. It is represented as SR. The symbol is SR. So, the example for this solid angle is radiant intensity. So, the unit of radiant intensity is watt per steradian. And the example for plane angle is angular velocity. It is represented in radian per second. So, this is an example for plane angle. And the third quantity is the derived quantity, and the unit used to represent is derived units. What is derived unit? The unit other than fundamental and supplementary units are the derived units. So, the derived units are dependent on the fundamental units. The units which depend on the fundamental units and the fundamental quantities are called as derived units. So, the example for derived units is mechanical units, like mass, velocity, force, acceleration, torque, etc. and electrical and magnetic units like current, voltage, power, magnetic flux, etc. and thermal units like specific heat capacity, latent heat, etc. So, these are all the examples for mechanical, electrical, magnetic and thermal units which comes under the derived unit. Let us derive the formula for a derived unit like force. What is the formula to find force? We know that force is equal to mass into acceleration. We know that the unit of mass, which is the fundamental quantity, is kilogram. What is the formula to find acceleration? We know that rate of change of velocity is acceleration. So, velocity is nothing but rate of change of displacement, which is meter per second. So, the rate of change of velocity is meter per second square, right. So, the unit of derived unit for force is kilogram meter per second square, or we can represent it as Newton. The derived unit for force is Newton or kilogram meter per second square. Next, we will calculate the unit for work or energy. We know that formula for work or energy is force into distance. Already we have calculated the unit for force, which is kilogram meter per second square or Newton. So, I am representing this as Newton, N. So, Newton into the distance in meter is the unit for force. For Newton, I can substitute here as kilogram meter per second square into meter. So, I will get kilogram meter square per second square is the unit of work or energy, or we can say it as joule. Joule is the unit for the derived quantity work from the fundamental quantities. Next, we will see what is dimensions. So, we know that every quantity has a quality which distinguishes it from other quantities. That unique quality of a quantity is called dimension. So, the unique quality of a quantity which is to be measured is called as dimension. So, we can define dimension as dimension of a physical quantity is nothing but the power raised to the fundamental quantities. So, the power raised to the fundamental quantities is called as the dimension of a physical quantity, and the formula used to represent the physical quantity in terms of fundamental quantities is called dimensional formula. So, the formula which is used to represent the physical quantities in terms of fundamental quantities is called as dimensional formula. Now, let us see the fundamental dimensional formula for fundamental quantities. So, the fundamental dimensions for the fundamental quantity and the fundamental or base units used to represent that fundamental quantities. First one is the length. So, the dimensional formula used to represent the fundamental quantity length is the capital N in the closed square bracket, and the unit for length is meter, the symbol is m. Second one is mass. So, you can represent the mass with the capital M in the square bracket. So, the unit of mass is kilogram and the symbol is kg. And the third dimension for fundamental quantity time is T, represent the square bracket, and the unit is second, the symbol is S. The fourth one is, the fourth fundamental or electrical quantity is the electric current, which is represented in the closed bracket as A, the unit is ampere, the symbol is A. And the fifth one is the absolute temperature. So, it is represented as theta, and the unit for absolute temperature is Kelvin, the symbol for is K. The sixth quantity is the luminous intensity I, and the unit is candela, the symbol is CD. And the seventh one is the amount of substance, which is represented as N, and the unit is mole, which is represented as MOL. So, these are the dimensional formula for this basic physical quantities. So, we can represent the physical quantity in terms of dimensional quantity, and the formula is called as dimensional formula. Now, we will derive the dimensional formula for some fundamental quantities. Example, first we will take velocity. What is the formula to find velocity? It is length by time. How will you represent the dimensional formula for length? Length is represented as capital N in closed bracket. So, length is represented as L and time in T. So, the dimensional formula for time T is T. So, velocity is represented as V. So, we can rearrange this equation as velocity V equal to L, can move time T to the numerator. So, T power minus 1. So, the dimensional formula for velocity is V equal to L into T power minus 1. Now, let us take another example, acceleration. What is the formula to find acceleration? It is rate of change of velocity with time. So, velocity by time is acceleration. So, we can represent acceleration as, already we have calculated the dimensional formula for velocity. So, substitute the dimensional formula here, L T power minus 1 divided by, the denominator has time T. So, dimensional formula is T. So, acceleration A. So, I will get acceleration A equal to, I am moving this time to the numerator. So, I will get L T power minus 2. So, this is the dimensional formula to calculate acceleration. Let us take another example, force. The formula to find force is mass into acceleration. We know that force is represented as F, and the unit dimensional formula for mass is m. Already we have calculated the acceleration, which is m L T power minus 2. Sorry, acceleration L T power minus 2. So, we will get m L T power minus 2. That is the dimensional formula for force. Next, we will calculate for charge. We know that charge equal to current into time. So, we will represent current as I and time in t. So, the charge, dimensional formula of the charge is I into t. The fifth quantity, work or energy, is given by force into distance. So, already we have calculated the force dimensional formula, which is m L t power minus 2, and along this we are having another distance, so into L. So, we will get m L square t power minus 2, which is the dimensional formula for work or energy. Sixth, we will calculate for power, which is work per time. So, already we have calculated here for work. So, m L square t power minus 2 by t, moving t to the numerator, will get m L square t power minus 3, which is the dimensional formula for power. Next, we will calculate for EMF or potential, which is work done by energy, work done by charge. Already we have calculated the dimensional formula for work and charge. So, we can write it as m L square t power minus 3. So, work done is m L square t power minus 2 divided by charge is I into t. So, the EMF or potential will be equal to m L square I power minus 1 t power minus 3. Let me take another example. This we will calculate for resistance. We know that resistance R equal to V by I, that is EMF by current. Already we have calculated the EMF. So, we will get m L square I power minus 1 t power minus 3. So, represent everything in a closed bracket divided by I. So, we will get the formula for resistance as m L square I power minus 2 t power minus 3. So, like this we can calculate the dimensional formula for all the fundamental quantities or all the derived quantities in terms of fundamental quantities like mass, length, time, current, etc. So, in today's class we have seen the introduction for measurement, what is measurement and what is instrument and what is measurand, and we have represented the physical quantity in terms of units, and we have seen what are units, what are all the types of units like fundamental units, derived units and supplementary units, and we have seen what are all the various examples for this units, and we have also seen the dimensional formula for the various derived quantities in terms of fundamental quantities. Thank you.